Welcome to today's lesson, and in this lesson we are going to look at collinear points. So the word collinear means points that are, or collinear points means points that rise on the same straight line. We can demonstrate that using the Cartesian plane. So I'm going to draw a Cartesian plane here. So that is this is our y-axis and this is our x-axis. Now we label our Cartesian plane. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can get to that point. Now we can identify 3 points. For example, we can take 4 and 4. We say that is our point A. Then we say 7, 5, 7, 5. That point, that is our point B. And we have 10, 6. We have 10 and 6. So we can call that point C. Now, if you take a ruler, you join the 3 points, you find that they form a straight line. So we say that in this case, we say A, B, and C are collinear. That means that they lie on the same straight line. Now we can take other points. For example, we can take that point and call it this point here, we call it P. We can take another one here, we can Q, and we can take another one here, we can say R. So you find that P, Q, and R, you cannot join a straight line. If you join a line, then you come up with, you join the 3 points, then you come up with that kind of line, the 2 lines. So we say P, or rather we say P, Q, and R are not collinear. They are not collinear. So those that is what we mean by collinear points. Points that rise on the same straight line. But now we don't have to draw the points on the Cartesian plane all the time to show that the 3 points are collinear. We can be able to verify by connecting the 3 points whether they are collinear or they are not collinear. Let's start with A, B. Let's start with A, B, and C. You say, let's write the coordinates. The coordinates of A are, we have 4. Let me check. We have 4 and 4. Then we have our B is 7 and 5. We have our C is 10 and 6. The y component is 6. Now, what we do, we have already discussed the column vector. So we can be able to get B is equals to AB, we get it is 7 minus 4, that is the x component, and 5 minus 4. So that will give us what? This will give us 3 and 1. So that is a column vector AB. If you don't know how to get the column vector, you can check my lesson on how to get column vector and also the position vector. Now again, we can be able to say AC. We can get the column vector AC, that is using AC, A and C. So we say it is 10 minus 4, 10 minus 4, and 6 minus 4. So that will give us what? 10 minus 6 is equal 10 minus that is 10 minus 4 is 6, and 6 minus 4 is 2. So that is a column vector. Now the column vector AC, we can factor out 2, and we will be left with when you factor out 2, you'll be left with 3 and 1. Now you find that this is the same vector as this one, and therefore we can say AC, or this implies that AC can be written as 2AB. 2 can be written as AC can be written as 2AB. When you are able to connect the two vectors A and B with A and B, and we have a common point. The common point here is A. A is common, and you have expressed AC in terms of AC in terms of AB. That is, AB is twice the length of AC, or AC is twice the length of AB. So we say that when you are able to express a vector in that format, we conclude that the 3 points are collinear. The 3 points are collinear. Now, if you try to do that with P, Q, and R, let's try that. Let's try that. So what I have done is I have created another page so that we remain with our other page. Now what we do is we get PQ. PQ is equals to the coordinates of P are 1 and 6. The coordinates of Q are 5 and 6. Hope you know how to get the coordinates. We get the x component and the y component, and finally we have our r. We have our r is 7 and 9. So we can get PQ. It is 6, not 6 but 5. It is 5 minus 1, and we have 6 minus 6. That will give us what? It is equals to 4, 0. So that is a column vector PQ. Let's get PR. PR is equals to our PR. We say it is we get the coordinates of R, and we say it is 7 minus 1, and we get 9 minus 6. So we say this is equals to 6. 9 minus 6 is 3. You see, now there is no way we can be able to write PQ in terms of PR. Even if we factor out 3 here, we will be left with 2 and 1. And you see, this is not, they are not equal. They are not equal. So we cannot express PQ in terms of PR. So we say P, Q, and R. PQ and R are not collinear. Hope you get that. P, Q, and R are not collinear because we cannot be able to express PQ as a scalar multiple of PR. If we go back to our question here, you can see here we have expressed AC is a multiple scalar of AB. Remember what we said about the scalar multiple. 2 is a scalar. 2 is a scalar. So this means that is why we concluded that AC and AC, A, B, and C are collinear. You must be able, for you to conclude that 3 points are collinear, you must be able to connect, to express one vector as a scalar multiple of the other. Maybe somewhere we can, if we, since we are saying AC, we are saying, just to note that, since we are saying AC is equals to 2AB, if we divide by 2 here, you divide by 2, you find that AB is equals to a half AC. You see now, a half here is a scalar. This is a scalar. So we can express AB as a scalar multiple of AC. And they share a common point A. So that is how we conclude that 2 points are collinear. We cannot express PQ in terms of, we can say why. Because, this is because we cannot express express PQ in terms of PR I hope that one is clear on collinear points. We can try some other points. Let's say we have now, without the Cartesian plane, how can we be able to show that 3 points are collinear? So we can say find out whether the following points are collinear. Let's say we have A. Our A is 1, 2. Our B is 6, 3. And our C is, can say 11, 4. Now, we don't have to draw the Cartesian plane to prove that these 3 points are collinear. What do? We can get AB is equals to, AB will be 6 minus 1 and 3 minus 2. So that will give us what? 5 and 1. We can express AC. AC is equals to 11 minus 1 and 4 minus 2. So that will give us what? This will give us 10 and 2, which we can write that we can factor out, factor out 5, 2 rather, and we are left with 5, 1. When you open the bracket, you multiply. If you multiply 2 times 5, you get 10. If you multiply 2 times 1, you get 2. So we have not changed our vector. Since now this vector here is AB, then we conclude that we can write AC is equals to 2AB. So concluding that the the 3 points, the 3 points are collinear. Meaning what? They lie on the same straight line. And if you plot them, you'll be able to prove, or you'll be able to see that they lie on the same straight line. Another example is that if we take point P, we say it is 1, 8. Q, we say it is 6, 5. And we have PR is 11, 2. Find whether they are collinear. So what do? We express, we can start with, in fact, we can also say PQ is equals to, it is 6 minus 1 and 5 minus 8. So that will give us what? 5 minus 3. We can get PR or even get QR. Let's try QR. QR is equals to 11 minus 6 and 2 minus 5. 2 minus 5. So this is equals to, that will give us 5, and this is minus 3. So you see, now these two vectors are the same. So we can say PQ is equals to QR. Well, you see now, they share a common point. Q is common